is definitely the one to watch out for because, you know.
Crap! Why should I watch out for me again? Or do you just like to watch?
Ladies and gentlemen, I'm Bodie One.
Glad you got to meet me! He's just magnetic. He's charismatic. He can't be stopped. So if he doesn't know you, he wants to know you. Subscribe!
Hey everybody, it's the Wannabe Doctor. Man Fred here. He's gonna help us out. He's obviously dead, but he's cool. I dig him. Anyway, alright, this is Dr. Hannah's AP2 class, and stay tuned for more.
Was the restoration of the blood volume. If a person has low blood volume, what can this affect? Remember, that comes before the last chapters. I don't have enough blood. The amount of blood I'm pumping is going to be reduced. And if I am reducing the amount of blood that I'm pumping, the blood that will be delivered to my organs is going to be reduced, and this will cause, you remember, if I have low tissue perfusion, this is what we call I'm in shock. Hypovolemic shock? Hypovolemic shock.
You had
You have low tissue perfusion, and if you have low tissue perfusion, you are in shock, like me. Alright, hypovolemic shock. Alright, so in order for me to restore the blood volume, I can give normal saline. If you remember why normal saline, what's normal saline? It's simply fluid that contains the same concentration of solutes like my cells. Why do you need to give normal saline, not hypotonic, not hypertonic? Because simply if you give hypotonic, what's going to happen? Fluid is going to be escaping from low solute concentration to the high solute concentration. My cells are going to be swelling. That's why you don't give water IV. You don't restore the blood volume by giving just pure water intravenous. Why? Because this is a hypotonic solution, and this will cause swelling of my cells. And if you remember, this is what we call the water intoxication or hypotonic hydration. If you remember also here, if I give a hypertonic solution, I'm given a solution that contains more solutes than my cells, what's going to happen? My cells are going to be losing the water to the outside, and as a result, my cells are going to be shrinking. Alright, so you use normal saline. Normal saline means I have the same concentration of solutes like the cells, not it's isotonic solution. It's not hypotonic, not hypertonic. Another way by which we did expand the blood volume is by giving plasma expanders. And if you remember, a very important protein that will be increasing the osmolarity of the blood, which is located normally in your plasma. This is called a albumin. The albumin is a protein that will be produced by the liver, and it's going to be kept in your circulation for you to maintain the same osmolarity as your cells. So the water is not moving in or out of your cells. So if I did have low albumin, these don't have enough albumin, what's going to happen as a result? If you remember, person will start to accumulate fluid around his cells, and like in the abdominal cavity, if you remember, this is what we call the ascites last time. So we're gonna be given this albumin in order for it to pull the water from the cells, pull the water from the interstitial fluid into your blood vessels, and this will restore your blood flow. If you remember, two other chemicals that we're gonna use that will have the same osmotic properties like the albumin. This was my heta starch and dextran, and those are carbohydrates. Those carbs will have the same osmotic effect, means they will be putting water to your vessels. But the problem here, they are more expensive and they will have more complications. If you remember, why do I still keep them as a choice? Heta starch and dextran. If I'm telling you that you have two jackets, one has less quality and is more expensive, why would you buy it?
I was just
if you
wondering
have
the same
another
thing.
choice which is less expensive and it's going to be of higher quality. Circumstances. If you remember, it's availability. If I don't have the other jacket, it's a good quality with a good price, I will go to the cheaper, to the more expensive with lower quality. Same concept on here. So you're gonna be using dextran, heta starch if I don't have the human albumin available. And if you remember, where do you get the purified human serum albumin? It's gonna be from human. That's why it's called human. So why we get it? Well, how we get it? By blood donation. So if I don't have people donating blood, I don't have purified human serum albumin, and at this point I will be in need to use heta starch and dextran. This is what we've discussed in terms of blood restoration. Moving on to blood transfusions. What are the different types of blood transfusions that we might have? First type of blood transfusion is given whole blood transfusion. I will give plasma with the red blood cells, everything included, all the blood. Whole blood transfusion. Who might need a whole blood transfusion? If somebody lost blood, in a car accident, I did have hemorrhage, did have acute bleeding, and at this point I need red blood cells, I need plasma proteins, I need blood volume. I'm losing everything by losing the blood, so I need everything to be taken from outside. So I will be given a whole blood transfusion. What if I have thalassemia, which is a hemolytic anemia, type of hemolytic anemia? I have breakdown, I have abnormal globin chains of the red blood cells, and those malformed red blood cells are going to be destroyed. So what's going to happen if you give me a whole blood transfusion every time? So this patient will need blood transfusion every few weeks because his red blood cells are going to be destroyed. So would you like to give him whole blood transfusion every time he gets a blood transfusion? Why not? He will have too many of the white blood cells. But they will be broken. What I need more of? Red blood cells, right? Just red blood cells. So if you did give this patient whole blood transfusion, what's going to happen? You are overloading his heart. So rather than pumping 5 liters, I'm pumping 1 extra liter. So you're overloading the heart, and then you're going to get rid of this extra fluid, and then you're going to overload it another time, and then you allow the patient to get rid of the fluid, and then you overload it, get rid, overload, overload. Every time you're gonna get a blood transfusion of whole blood, you're gonna be overloading the heart. So you don't wanna overload the heart of your patient. So here, we're gonna be using a different type of blood transfusion, which I will be given only red blood cells. This is gonna be my packed red blood cell transfusion. You're gonna be separating the plasma, you're gonna take out the red blood cells, and you're gonna give just the red blood cells. This is called the packed red blood cell transfusion. And when do I need packed red blood cell transfusion? If I need recurrent blood supply in order to maintain a normal oxygen carrying capacity. Alright, so if a person has anemia for whatever reason, I don't want to give whole blood transfusion, I will be given instead packed red blood cell transfusion. Another type of blood transfusions that you will have here, a person who has a problem only with restoring his blood volume. He doesn't have a problem with the red blood cells. Like what? Like if a person got burns, he's oozing fluid out. Did I lose any of the red blood cells? No. But what I've lost is plasma. I've lost lots of plasma. So instead of giving whole blood transfusion, and at this point you're gonna have extra red blood cells. You don't want to get extra red blood cells in the blood because this will increase the blood viscosity, if you remember. So I will be given only what the patient needs, which is gonna be my plasma. So I will give only plasma transfusion. And where else would you need to give plasma? If a person, for example, has hemophilia. What's hemophilia? Hemo is blood, and philia, love. So this is a patient who loves blood. He's gonna be bleeding all the time. All right, so because of
Low coagulant.
I don't mean by loving blood, it's a Dracula, no? He is bleeding, right? So you see on here, he has missing coagulation factors. And if I don't have one of those coagulation factors that we discussed last time, I won't be able to form a blood clot, I won't be able to coagulate the blood to stop the bleeding, so this patient will have more tendency to bleed. So at this point, do you need to transfuse red blood cells? No.
No.
What I need only is the plasma proteins. So you can give only plasma transfusion in this case. So how many patients can you help by blood transfusion? What do you think so far? You can help a patient who has anemia. You can help a patient who has burns because he lost lots of plasma. You might help a patient who has missing coagulation factor, hemophilia. You can help a patient who is in an emergency and he needs a whole blood transfusion because he did bleed. So we're gonna be doing a blood donation, and this is gonna be for 5 extra points towards your final exam grade. All right, so I will be collecting the receipts on the final exam day. All right, so whatever location you prefer, doesn't have to be this one.
Well, no, just my general, you came to it after I.
All right, so doesn't have to be in this specific location. Any location will be accepting blood. It's gonna be fine. So if you do have any health problems that prevents you from donating blood, not fear. So if you have anemic, if you have traveled out of the US to certain areas, they will not accept blood from you. So they will check your hemoglobin levels, the hematocrit level, and according to the results, they will decide whether or not to take a blood donation from you. So if you did go and they did not accept a blood donation from you because of you have low body weight, whatever reason, just ask them for a receipt that you did try to donate blood, and just bring it on with you on the family 10 days. This is going to be adding the same 5 pounds or trying to. All right.
In terms of like receipt, I donated blood a couple weeks ago. What kind of receipt would you need for that?
They will give you a sheet that you did donate blood, and this is addressed to who it might concern. So when you ask them, they don't regularly give it out to you, but when you ask them, they will. All right. So in a couple of weeks, they should be sending you your blood type
I got it.
by mail. So if you can get a copy of this, write your name on it. This is going to be fine. This is going to be substituting or so just any proof that you did donate blood. Because if you did try to donate blood another time, they will not accept.
I can't do it for like another
Yeah.
months.
All right. So moving on to blood typing. What's an antigen? What's an antigen? An antigen is simply any chemical compound that can trigger an immunological reaction. So what this means? This means simply why the bacteria is gonna be attacked by your immune system, but your cells will not be attacked by the immune system. Why do you think? Both are gonna be full of fats, proteins. You have inside nucleic acid. Why? Your immune system will decide to attack any bacterial cell, but not your cell, own cells. Normally,
Markers on the cell.
I have markers on the cells. So you have like a fingerprint on your cells that determines whether or not this cell belongs to you. And what triggers the immune response is going to be considered an antigen. So an antigen is simply a chemical compound that triggers an immunological reaction. All right. So if I have a chemical compound different from the bacteria, but it does not trigger an immunological reaction, although they are different, it's part of my fingerprint, this is not going to be considered an antigen. So an antigen simply means a chemical compound that triggers an immunological reaction. Activates your immune system for the immune system to attack this antigen. All right? So one simply, you cannot donate an organ to any person.
Their body will reject the organ.
The recipient body immune system will detect that this is something from outside, it's non-self, and will start to attack it. So we need to match a donor with a recipient. Same concept in the blood. In the blood cells, on the red blood cells, I have antigens that will be able to trigger an immunological reaction. Those antigens are what we're going to be classifying the blood types according. So first way of classification of the blood types is going to be called the ABO blood type. What's an ABO blood typing? Simply speaking, I have a chromosome from my father, I have a chromosome from my mother, and they will carry a gene coding either for A antigen or for the B antigen. So if I have a chromosome from my father that carries gene coding for the A antigen, and my mother chromosome doesn't carry any, either A or B. So what's going to happen? I will have only antigen A on the surface of my red blood cells. What if you have a chromosome from your father that carries antigen, the gene coding for antigen A, and the chromosome from your mother carries the gene coding for antigen B? So I have co-dominance between those two genes. I don't have a recessive gene, I don't have a dominant gene. Whenever they are present, they will be presented. So you see on here, a blood cell of mine will have both antigen A and antigen. Why? Because simply I have one chromosome that carries antigen A, another chromosome that carries antigen B, or the gene coding for antigen B. Alright, so what if I have a chromosome that carries A, another chromosome that carries A also? I'm still A, no change. The only antigen that I will be able to present on the surface of my cells is going to be antigen A. What if I did get chromosome from my father that doesn't code for antigen A or B, and I get a chromosome from my mother that doesn't code neither for antigen A or B? So will I have any antigen on the surface of my cells? And would I have any antigen either A or B? No. So having nothing presented, I am a blood group type O. So what are the different blood groups? I might have only antigen A presented on the surface of my cells. So I'm a blood group type A. If I have only antigen B presented on the surface of my cells, I am a blood group type B. If I have both antigen A and antigen B presented on the surface of my cells, I am a blood group type AB. And if I don't have neither A or B on the surface of my cells, I'm a blood group type O. So according to the AB system, ABO blood grouping, we're gonna be either blood group type A, means our cells are presenting only antigen A, or blood group type B, means my red blood cells are only presenting antigen B on their surface. Being a blood group type AB means I am presenting both antigen A and B on the surface of my cells. Being a blood group type O means I'm not presenting neither A or B. So can a person, can a father who is a blood group type A and a mother who is a blood group type B get an O blood type and a blood type O child? If I have a blood group type A, my wife is a blood group type B, can we have a child who is a blood group type O? So can, yes or no?
Yeah, I think yes, maybe.
So no, they cannot get a child who is a blood group type O, an A person married to a B person.
Don't know.
Yes, they can.
Yes, I can. Yes, I can.
It's either yes or no. It's either yes or no. Yes, they can.
Sure, yes.
No, they can't. Alright, why yes they can? If I have a blood group type A, the father is blood group type A, so he either has antigen A coded on one chromosome and nothing on the other, or having the coding for antigen A on both chromosomes. So I'm either AA or AO, being a blood group type A. And the mother might be BB or BO. So the father can form sperms who carry the gene or don't carry the gene. And the mother can form eggs who will either carry the gene or they don't carry the gene. It's BO. So I can have a child who's AB. I can have a child who's B. And I can have a child who's A, and I can have a child who's O, blood group type O. 25% chance for each of the 4 blood types. Alright?
How up top you have like the AA and the AO, is that what we determine if it's A positive or A negative?
positive and negative. This is another blood group,
That's RH factoring.
RH. All right. So we're focusing here on how many antigens? 2 antigens, either A or B. All right, and they will be coded at the same site on the chromosome. All right, so who can give blood to whom? What determines? What determines is simply the antigen on the surface of the transfused cells to what person? So the general to not give an antigen that doesn't exist on the blood cells of the recipient. Why? Because if I don't have the antigen on my cells, this antigen that I will be receiving is going to be considered a non-self antigen, and I will start to attack. So what antigen do I have here if I have blood group type A? I have antigen A. So what is the non-self antigen for me that I don't have?
B.
B. So my immune system will recognize antigen B and will attack it, releasing antibodies against antigen B. This is what we call anti-B. If I'm blood group type B, so which antigen I don't have on the surface of my cells? Antigen A. So antigen A for me is a non-self antigen, and whenever I will get exposed to this antigen, I will start to attack it because this is a non-self antigen, and my immune system is going to be producing anti-A. If I'm blood group type AB, I have both antigen A and B. So would I be producing anti-A or anti-B? No. Why? Because simply both antigens are self-antigens. Both are a self-antigen. You don't normally attack your own antigens. All right? So you don't produce anti-A, you don't produce anti-B. In a blood group type O, which one am I missing? I'm missing A, I'm missing B, so both are for me non-self antigens, and my immune system will start to attack both of them. I am able to produce anti-A and anti-antibodies.
Can you have an anti-O?
We don't have anti-nothing because O simply means
Nothing. Makes sense.
O means you don't have neither A or B, you have nothing presented.
I mean, I knew it was universal, I just didn't know.
We're gonna get to how common is it. Alright. So the key here in blood transfusion to not give the cell, the antigen to a person who is capable to produce antibody against your antigen, the transfused antigen. So if I have antigen whatever, don't give this antigen to a person who is able to produce the antibody against this antigen. This is the key. So, blood group type A. Can I receive blood from another blood group type A? Yes. Yes or no?
Yes.
So what antigen do I have on the surface of my cells? A. Would it be anti-A?
No.
No. So you can get blood from an A. Can I receive blood from a blood group type B, from a person who has a blood group type B?
No.
No. Why? Because the antigen, which is antigen B, is going to meet anti-B. So what's going to happen if the antigen meets the antibody? The transfused cells are going to be attacked by the immune system. They will get destroyed, and the hemoglobin, which is supposed to be broken down in the sinusoidal capillaries, this will be released out in my bloodstream. And if this gets released in the bloodstream, it's going to be filtered out in the kidney tubules. Blocking the kidney tubules will result in renal failure.
Oh.
Alright? If you give an antigen to a person who is capable to produce antibodies against this antigen. Alright? So you don't want to have this. So you will not be given a blood transfusion from a person who is a blood group type B. Can I get a blood transfusion from a person who is AB?
No.
No?
No.
Yes, I can get a blood transfusion from an AB. What antigens do I have in here? Under my AB cells? A and B. So would any antigen meet an antibody here?
Yes.
Yes, so you have antigen B that's gonna meet anti-B, so those cells gonna be destroyed. So you see on here, you cannot receive blood from an AB person. Can I receive blood from an O person? What do you
Yes.
think?
Yes.
Yes, why? Because you don't have an antigen on the cells that will be meeting its antibody. So you have anti-B, but you don't have antigen B on the surface of the O cells, so you can't receive blood type O. Alright? What if I'm blood group type B? Can I receive blood from an A person?
No.
Antigen A will meet anti-A, so the cells will be broken down, so you don't want this to happen, so you won't give blood type A to a B person. Can I receive blood from a B person?
Yes.
Because antigen B will not meet anti-B because I don't produce anti-B from my immune system. Can I receive a blood from an AB person?
No.
No, why? Because antigen A is on the surface of those cells, going to be attacked by the anti-A, so you cannot receive blood from an AB person. Can you receive blood from an O person?
Yes.
That's why, because simply you don't have an antigen, that's going to mean the anti-A, so you don't have a problem. Alright, so I can receive blood from an O person. How about blood group type AB? Can I receive blood from an A person?
Yeah.
What antigen do I have in here?
Oh, hold on.
Antigen A. Do I meet the anti-A here? Do I produce anti-A in an AB person? No. So you can't get blood. The antigen will not meet the antibody. So I can't get blood from an A person. Can I receive blood from a B person?
Yes.
Why? Because the antigen will not meet anti-B. So you can't receive blood from a B person. You have no problem with this.
You said, wait a minute, what?
There's no antigen.
You have antigen A, you have antigen B. Do I produce anti-A or anti-B antibodies against antigen A or antigen B in
Yes.
AB person?
Yes.
Yes or no? No, you don't. You don't produce antibodies.
Oh, yeah, no.
If
Yeah, 'cause
are
you
not
kill each other.
producing antibodies,
That's right.
would the A antigen meet anti-A? Yes or no? No, why? Because simply you don't produce it. Would the B antigen meet the anti-B in an AB person? No, why? Because simply you do not produce anti-B because you have B antigen on the surface of your cells. If you do have the antigen, you don't produce the antibody against this antigen. Can I receive blood from an AB person? Yes, the two antigens will not meet any of the antibodies, so you can't receive blood from an AB person. Can I receive blood from an O person? Can I receive blood from an O person? What do you
Yes.
think?
Yes.
You don't have antigen, you don't have antibody, no antibody, antigen-antibody reaction.
And them AB people are
So
lucky.
you can receive blood from an O person.
They lucky. Anything ever happens to them, they good.
Alright, what if I am a blood group type O? Can I get blood from an A person?
No.
So why? Because I have antigen A and I'm producing anti-A, so the antigen will meet its antibody, so the cell is going to be destroyed. So you cannot receive blood from an A person. Can I receive blood from a B person?
Nope.
No. Why? Because antigen A, antigen B will meet the anti-B, the cell is going to be destroyed. You cannot receive blood from a B person. Can I receive blood from an AB person?
No.
Both antigens are going to meet both antibodies, more destruction will take place, so you cannot receive blood from an AB person. Can I receive blood from an O person?
Yes.
Why? Because simply the transfused O red blood cells will not meet their antigen because they are antibodies because simply they don't present the surface antigen. Right? So the only one I can receive from is gonna be a blood group type O. Alright, so I know that people who are blood group type O are so angry now. I'm giving everybody, I'm not getting blood from anybody except for myself. Alright, so don't feel sad about it. Alright, because simply you are representing more than 40% of the general population. Alright. This is the most common blood type. So who's the blood group type O? We have no idea. Okay, so most of you, at least half of you, will be blood group type O.
Type B.
Be positive. Okay. Question.
Yes.
You say you're gonna get into the positive and negative?
Yes, I will go to the positive and negative now. Yes. Alright, so this is in terms of the ABO blood grouping. What's the positive and the negative? This is a different antigen other than the ABO blood grouping. Actually, we have many antigens. We are focusing only on one of them, which is my D antigen. D antigen is a different antigen rather than A and B. If I have the D antigen on the surface of my cells, I am an Rh positive. And if I don't have the D antigen on the surface of my cells, I am an Rh negative. Alright, so this is much easier. Here, I have only one antigen that we are focusing on. If I have the gene coding for this antigen, either on one chromosome, only on one chromosome out of two, I would present the antigen. So I will be Rh positive. Or if I have the gene coding for antigen D on both chromosomes, I will still be presenting the antigen and I will still be an Rh positive. What is meant by being Rh negative means you don't have the antigen. In other words, you don't have the gene coding for antigen D on both chromosomes. Alright, so if I am an Rh positive, means I have the gene coding either on one or both chromosomes, and as a result, I will be presenting the antigen on the surface of my red blood cells, and I will be Rh positive. Rh negative means I don't have the antigen D on the surface of my cells, or in other words, I don't have the gene coding for antigen D on both of my chromosomes. The ones that I've got from my father and the ones that I've got from my mother. Alright?
Is there a reason why that would happen genetically?
The reason?
Yeah.
So it's a variation, a normal variation. So it's not a mutation, it's not something normal. It's like having a different skin color or different appearance of the body, different density of the bone, or those are going to be variations. Alright? If it does not interfere with the regular daily activities, it's not going to be considered a disease, and it's going to be considered a normal variation. Alright? Alright, so looking here, Rh positive, Rh negative, so it's going to be the same concept. Do not give the antigen to a person who's capable to produce the antibody. So who's going to be capable to produce the antibody against this antigen is going to be Rh negative. Because the D antigen for me, do I have D antigen on the surface of my cells? No, and if I don't, this is going to be considered a non-self antigen. And if it's a non-self antigen, my immune system will recognize it and will be producing anti-D. Start to attack those transfused cells, but actually it's not like in the ABO blood group. In the ABO blood grouping, you're gonna be producing the anti-A, anti-B very early during fetal life. Or compared to the anti-D, you need to recognize antigen D first, and then
You know, I can't do all the heavy lifting here.
produce anti-D later on. So if you've got a blood transfusion from an Rh positive, it will pass unnoticed for the first time. So I can get, if I am an Rh negative and I did bleed and the only blood available is Rh positive, would you give me this blood transfusion or you will let me die?
I'm giving you that blood.
Hopefully you're gonna give me this blood transfusion. Don't worry about having a hemolysis. Don't worry about the breakdown. If I don't have a previous blood transfusion by an Rh positive, no reaction will take place only in the first time. This is gonna take a while for my immune system to recognize it and produce anti-D to attack those transfused cells. So the first time will pass unnoticed. Later on,
Not
if
so
you
much.
did re-expose, if you get re-exposed to the D antigen, you're gonna have the same reaction, mismatched blood transfusion reaction that will result. You're gonna be breaking down the transfused cells, releasing the hemoglobin, blocking the kidney tubules, having renal failure. It's all the same like a mismatched blood transfusion in the ABO blood group. All right, so we have another aspect here in terms of Rh, which is if a woman
She got one side.
So a woman got married and she was Rh negative. What I mean by Rh negative, she doesn't have D antigen on the surface of her red blood cells. She doesn't have antigen D. To a guy here, who is Rh positive. Let's expect that this guy is D capital D capital. Means he has
Antigen.
gene coding for the antigen on both chromosomes. Alright, and she will be D smalls. Means she doesn't have a gene coding for antigen D on both of her chromosomes. Alright? So congratulations, they got married. Right? Don't need it anymore.
Toss us to the side.
And she got pregnant.
That's why he ain't there no more.
Alright, she's pregnant and all his sperms were carrying the gene coding for the antigen D, and all of her eggs are gonna have the chromosomes that won't carry antigen D. So the baby here is gonna be D capital D small. So he is gonna be Rh positive or negative? Positive. Alright, is there any problem so far?
No.
No. Do you normally have exposure to the immune system of the mother during pregnancy? What do you think? Do you have the exact same antigens like your mother? No. No. How come the immune system of your mother did not reject you when you were a baby? You don't have exposure. You don't have exposure. You have the placental barrier that prevents the exposure of the baby antigens to the mother's immune system, for the mother to not attack her baby. Alright, so normally we don't have any exposure to the baby antigen. Alright, so what is the problem? If I don't have exposure, I have no problem. Alright, the first baby will be born. Congratulations. And he's gonna be healthy. I have no problem with that. But what happens during labor? some of the baby red blood cells carrying the D antigen are going to be traveling to the bloodstream of the mother. So when you're cutting the placenta, cutting the umbilical cord, you have stitches, you have the blood of the mother. So the D antigen will be exposed to the mother's immune system. Do I have a problem so far? Not yet. Alright? So what's going to happen when the immune system gets exposed to the D antigen, it's going to be producing the anti-D. And the anti-D is of an IgG, a type of immunoglobulins, which is too small. Small type of immunoglobulins, as we're going to mention later in the immune system. The problem is when she gets pregnant another time, so she got pregnant another time, her baby, her second baby, will also be Rh positive. Now the D antigen still didn't get exposed, but the anti-D formed from last pregnancy, from last labor.
Well, let's see what you got. Hit it! You got Moxie.
You're going to be breaking down the baby red blood cells. This condition is called erythroblastosis fetalis. Erythroblastosis fetalis. You see on here? This is baby with erythroblastosis fetalis. I have major hemolysis. You can turn off the light, please. So major immunological reaction causing swelling of the tissues of the baby. I have deep jaundice. Why deep jaundice? Remember, when you break down red blood cells, what's gonna this result in? Not liver failure. I will be producing lots of bilirubin. Remember, when you break down the heme part, you're gonna be recycling the iron, and the porphyria is gonna be producing bilirubin. So that's why I would have this yellowish discoloration of the baby. So most likely, this baby is gonna be either dead during pregnancy or will shortly die unless he gets a blood transfusion. I do need to replace the blood of the baby. Either will shortly die after labor or will die will be a stillbirth.
Doctors be able to find this out before?
I couldn't hear you. Can you repeat, please?
Can you detect this before?
Yeah, so you know already that a woman is gonna be Rh negative, and regardless of the father, we're gonna be given something to prevent it from taking place. What do you think you will need to do? If you have this is problems you have, how do you think you will need to prevent it?
Have another carrier?
Another carrier?
Yeah, like in vitro to another person
So
that has a not a negative
something
thing.
less expensive to be approved by the
You didn't say expenses.
something less expensive to be approved by the insurance? What do you think?
You know?
That's the reality of the
Can
situation.
we check her blood to see if,
She is Rh negative?
yes.
Yeah, we
and
did
then-
identify that she is
if
Rh
she is
negative.
done, when she's pregnant, I don't know what month they give her,
A shot, what
a
shot?
or something.
What's in this shot?
Iron.
Antigen?
Do you give her the antigen for her to kill the
Well,
first baby? What do you think?
Kind of reverse of the
Immune blockers, so you're gonna need to block the mother's immune system to not attack the second baby?
Yeah. Yeah.
But if I block the immune system of the mother, this is going to be getting me in a lot of troubles. Because the mother will not be able to defend herself, so she will not be able to defend her baby against pathogens. So you don't want to give her immunosuppressants.
The mother immunosuppressant when she's pregnant, right? Some, not, I mean, not good, but.
What you can you explain?
You can't do that.
I thought, like, when you said, like when a woman becomes pregnant, I mean, like, her immune being suppressed play a part of it. So
Yeah, partly, but it doesn't have, you don't want to have more suppression to the immune system, because this puts her at risk of getting infections as well as the baby.
So it's only like that when she first gets pregnant.
Yeah, how would I interfere? How would I prevent this from taking place? What do you think I need to give her? A shot. What shot? What's inside the shot? I would simply give her anti-D. Does this seem logical? Is this logical?
Yeah.
What do you think?
Yeah.
Actually, my problem is in the presence of the anti-D. How come the prevention is by giving her the same thing that causes my problem?
If they want to attack you.
Because it's gonna
So
fight.
recognize it.
Fire
What's
with
the
fire.
Initial problem? What caused the initial problem is
The code.
those red blood cells that had trouble from the first pregnancy during labor, right? So what if I did kill those cells before they get exposed to the mother's immune system? If I kill those cells before I get exposure to the mother's immune system, will the mother form anti-D?
No.
No. So I will be given the mother anti-D from outside.
Fighting fire with fire.
Around the time of labor, with every pregnancy, miscarriage, and labor. Alright? Giving her the shot prevents the exposure of the immune system to the D antigen, because simply I will be attacking those red blood cells of the baby before they get exposed to the immune system. So the immune system did not recognize them, did not produce antibodies against the D antigen.
See, that's cool as hell.
Alright? So with every single labor, miscarriage, you're gonna need to give her a shot. What's inside the shot again is
Anti-D.
anti-D. You are preventing the exposure to the D antigen.
So what, I mean.
So why is this D anti-D you're giving her will not affect her next baby? Simply because it has a certain life duration. So it will not be kept for life. It's going to be destroyed after a while, so it will have no effect later on. Compared to the anti-D she will be producing by her immune system, actually she is the one who's going to be producing it, so it's going to be produced for life. So the one I'm giving her is temporary. It has a temporary effect. Compared to the ones that she will be producing, it's a permanent production of the anti-D. Alright? Again, what do we call the case of hemolysis of the red blood cells of the baby due to the passage of the anti-D through the placenta?
Erythroblastosis fetalis.
Erythroblastosis fetalis.
Do they give it to the IV or is it like a shot? They have to do.
So they give it free. I'm not sure of the route. I'm not sure of the route, but I don't remember the route.
How do you spell that second word?
Erythroblastosis.
No, the blastosis.
Erythro.
Just the blastosis.
So how would they would be identifying the blood type? How would we look at the antigen on the surface of the red blood cell? We're going to simply get the antibodies. So we're going to have anti-D, anti-A, anti-B, and anti-B. And then I will put drops of blood and mix them with the anti-A, anti-B, and anti-D. If you've got a reaction, this means what for you? This means that the antigen did meet the antibody. Antigen meeting the antibody will cause an immunologic reaction. If it didn't meet the antibody, no reaction would be taking place. So look on here. If I did have a reaction with anti-A and anti-B, this means the blood cells carry what antigens? So again, when would you have a reaction? If the antigen meets the antibody. So here, if I have a reaction with anti-A, this means I have antigen A.
Antigen A.
If I have a reaction with anti-B, this means I have
Antigen B.
Antigen B. So what is the blood type that has both antigen A and antigen B?
AB.
AB. What if I did have a reaction only with anti-A? So I have what antigen on the surface of my cells?
A.
Antigen A. And no reaction with anti-B, so I don't have B, I have only A. So if I have only A, what is my blood type?
A.
Blood type A. If I have a reaction only with anti-B, and I don't have a reaction with anti-A, so having a reaction tells me that I have the antigen. So having a reaction with anti-B, I have antigen B on the surface of my cells. So I'm a blood group type
B.
B. If I didn't see a reaction, neither with anti-A or with anti-B, this means I don't have antigen A
Or B.
and I don't have antigen
B.
If I don't have antigen A and antigen B, this means I am
Type O.
blood group type O. Yes.
What is the reaction?
As you see here, the cells, the red blood cells, are going to be attached together. You see the granulation.
Okay.
This is what we call the agglutination reaction. It's like sticking the red blood cells together, like glue.
So it's overcoagulating.
It's not coagulating, it's attaching the cells together.
Okay.
So you see, cells are
Fusing.
attached, not scattered all over the
Okay.
sample. They are going to be agglutinated in granules. So I have this granular appearance if I have a reaction. All right? Questions? Questions? So, in a transfusion reaction, what's going to be my problem? I have a problem only if the donor cells are going to be presenting the antigen that matches the antibody produced by the recipient. So, and as a result, what's going to happen? The transfused cells are going to be agglutinated, attached together, and if you remember, how many red blood cells can pass through a capillary at a time?
One.
Only one. So if you attach 5 in the same time, if you attach 10 in the same time, would they be able to pass through the tiny capillaries?
No.
And as a result, you're gonna be blocking the small vessels. What else? If you try to squeeze those 10 red blood cells to pass at the same time, because you are attaching them together, what's gonna happen to those red blood cells? They will be ruptured. And as a rupture, what's inside those red blood cells? Those red blood cells that will be released to the outside of my hemoglobin. So the hemoglobin is not normally released in the circulation. Why is it a problem to have hemoglobin released freely in the circulation? Because simply it's not negatively charged, it's not big enough to prevent its filtration by the filtration membrane in the glomeruli of the kidney. So if the hemoglobin travels from the filtration membrane, it's gonna be blocking the kidney tubules. And if you block the kidney tubules because of this accumulated hemoglobin, what's gonna happen as a result? Not able to filter anymore, and the reduction in the filtration, this is what we've considered a renal failure. All right? Questions?
I mean, I realize it's not the 19th century anymore. Most people probably do the test before they administer the transfusion. If for some reason they got blood that wasn't matching with their own, how would you treat it?
The test will not take a minute.
Okay.
So if you did have this here, if you did for any reason got a mistake, an error,
How do you treat it?
and you're gonna need to give more of the blood, because simply all the transfused blood is gonna be destroyed. So you actually don't want to have any diminished oxygen carrying capacity.
Okay.
Because this is the main reason you've given blood transfusions. So those transfused cells are going to be broken down. So you need to give him a blood transfusion with
the right
blood type. This is the first thing. The other thing is to give him iron chelating, to take away the extra iron you're going to be adding to the system. Also, you're going to need to give him something to block the hemoglobin and to chelate it, to make it more solid. Alright? But this is something that we don't see. Alright? And it has very major complications. It's not guaranteed that you can make it with this person without having complications. Alright? Alright, so moving on to homeostatic imbalances of both blood and immunity after we discuss the immune system. So we're going to skip the homeostatic imbalances of the blood. We're going to be covering the immune system now. And after we're done with immunity, we're going to discuss both the homeostatic imbalances of the immunity and blood together. That's it. Why do we have an immune system? Why do you think? This is our resistance against any disease. And the immune system is going to be two systems combined together. We have an innate, which is non-specific defense system. It's going to be acting non-specifically against any bacteria, any virus. It does not differentiate between the different types of pathogens. And I have the adaptive immune defense system. This is going to be specific. It targets specific pathogens. So, for example, part of the adaptive immunity is going to be a cell that's going to be producing antibodies against antigen A. So those antibodies are only targeting antigen A. I have a specific type of immunity. Compared to your skin, what do you think? Is the skin preventing specific types of bacteria and allowing others, or it's going to be preventing all the bacteria, regardless of their type? All of them, not specific. So again, what is the innate immunity? This is a non-specific immunity. and this will act as the first lines of defense in your body. Compared to the adaptive immunity, you're gonna have to recognize the antigens that you're targeting. You're gonna be only targeting this specific antigen, not any other antigen. All right, like what non-specific defenses that we have? We have first the surface barriers. Like what surface barriers? Like my skin, like my mucous membranes. So if I ingest a bacteria, it's gonna get in contact with the mucous membrane of my stomach. And the mucus of the stomach, the mucus secretions of my stomach will contain hydrolytic enzymes, will contain hydrochloric acid. And hydrochloric acid, and the hydrolytic enzyme is going to be breaking down any bacteria. It doesn't matter what type of bacteria you're going to be breaking down. You're going to be breaking down. So you see here, I am a non-specific immune defense, an innate immune defense. Same for my skin. My skin will be preventing the invasion of all the pathogens. I'm not specific to any of the pathogens. I will have also cells that will act non-specifically to target the pathogens. I will have immune responses like the inflammation, like fever, which are all non-specific. They are part of the innate immune response. I have chemicals that will be released non-specifically, and they will help against any kind of pathogen. Again, all of those are part of your innate immune system. Compared to the adaptive immune system, I will have two major parts of the adaptive immune system. First part of the adaptive immune system, I will rely on a type of lymphocytes. If you remember, those are called my B lymphocytes. The other type of cells, this is going to be my T lymphocytes, and this will be responsible for another type of adaptive immunological reaction. So starting first with the innate immunity. My skin, mucous membranes, this is the first line of defense that would be facing any pathogen. My skin is going to be preventing the invasion. My mucous membranes are going to be releasing defensins, lysozymes, acidity, mucus. All those are going to be acting as a barrier against the pathogens from invading my tissues. I am blocking the invasion of the pathogens. Other non-specific innate immune defenses, those are going to be the internal cells. Internal cells like my phagocytes, which are either neutrophils or macrophages. If you remember, where did I get the tissue macrophages from? You remember what are the two classes of white blood cells that we mentioned last time? Granulocytes and agranulocytes. And what are the three types of granulocytes? Neutrophils, basophils, and eosinophils. And the agranulocytes, those were my monocytes and lymphocytes, right? So, where do I get the tissue macrophages from? They are actually monocytes that did migrate from your circulation and living now in your organs. So in your lungs, we're going to have the macrophages called dust cells. In the liver, we're going to have the macrophages called Kupffer cells. In the nervous system, we're going to have macrophages called the microglial cells. All those are actually monocytes that did migrate to your organs. And this is going to be a non-specific immune cell. So whatever bacteria that will be passing into your organ, those macrophages will engulf them, will break them down. Same concept for my neutrophils. If you remember, what are the different names that we've given to the neutrophils? First, why did we call them neutrophils? Because they have cytoplasmic granules that will accept both the acidic and the basic dyes. That's why we call them neutrophils. If you remember, other names for the neutrophils, those are my polymorph nuclear leukocytes, and we call them, because they have a very high phagocytic activity, my bacteria slayers. They are targeting any bacteria. They act non-specifically. Alright, so again, first two innate immune cells, those are going to be my macrophages and neutrophils. Another innate immune cell, this is going to be my natural killer cell, and the other names that we give to the natural killer cells, those are the body policemen. Alright, so what they are doing, natural killer cells, they are checking your ID. Alright, so they are circulating, they keep move between your cells, and they will check the ID for your cells. What is your ID?
The man at the door.
What is your ID? Alright, so what is your ID? So any cell who will not be presenting its ID, I will. I'm called killer, so what will I do with the killer? I will kill it.
Nice and brute force.
So if I got a cell of my body that is infected by a virus, it will fail to present self-antigen. And if it fails to present the self-antigen, the natural killer cell will bind to it and will destroy it from inside. Actually, it will kill it by a decent way. It will convince it to kill it itself.
Okay.
Alright? Rather than kill it, it will convince it to kill itself. This is what we call apoptosis. It's regulated cell death. So I will be enhancing the apoptosis of those viral infected cells, of the cancer cells. Do we normally produce cancer cells?
We do, but we get rid of them like all the time.
All the time, but
We don't
the
have
natural
to.
killer cells are there to find them and to kill them. Alright, so what is the cells that will be attacking the cancer cells even before the activation of the adaptive immune system is going to be my natural killer cell. Natural killer cells. I am an innate immune cell. I am non-specific. Do I target any specific cancer? Do I target any specific viral infection? No. I am attacking any cell that fails to present self-antigen. I am acting non-specifically. That's why I consider it part of my innate immunity. Alright? Question?
Oh, y'all can actually get cancer because you lack natural cells?
Or you are rapidly proliferating the cell with a mutation above the ability of the natural killer cells to get rid of.
Right.
So if you have lots of irritation, that will be increasing the number of cancer cells beyond the ability of the natural killer cells to attack, and beyond the ability of the T lymphocytes, as we're going to mention next time, to attack, to get rid of the cancer cells. At this point, it will be disease will progress to an extent where I'm not able to deal with normally. It's the same concept with infection. Why, if I do have all those immune defenses, why would I develop an infection? Because simply the rate of the proliferation of the bacteria or the pathogen is higher than the ability of my immune system to get rid of it. Alright? So it's a matter of balance. If it exceeds my ability to get rid of the bacteria, if it exceeds my ability to get rid of the cancer cells, I will get a cancer, I will get an infection. Alright? It's a balance that we have.
You're getting overwhelmed.
Alright, so 3 innate immune cells that we've seen. Natural killer cells, macrophages, and neutrophils. Natural killer cells, macrophages, and neutrophils. Another, an example of the body's first line of defense is going to be macrophages, fever, inflammation, mucus. Which one? Very first line is going to be the surface barrier, your skin and mucus membranes releasing mucus. So the mucus here is one of the first lines of defense. surface value. It's part of my surface values.
So, when I was sick last week and the week before, and I was telling you that my mucus, no offense, like not a TMI, it was yellow, so that has to do with that.
So this is pus. It's different than the immune. So this is actually, you've got a war between the bacteria and your immune cells. So some of your immune cells are destroyed, some of the bacterial cells are destroyed, and they will accumulate together and will form this mucus. Or actually, it's not this real mucus that you normally produce, but it has dead cells inside.
That's why it's yellow.
Yes, it might be yellow, it might be green. It's according to the type of bacteria causing the infection. All right, but this is not the normal mucus that acts as a surface barrier. This is a mucus with infection inside, and lots of bacteria cells dead. All right.
Also, question, that's why a lot of people don't like to drink a lot of dairy. So, is there a reason why? Because
Drink a lot of what?
dairy, the milk that comes from a cow.
Dairy, like they don't drink lots of dairy to do what? So I'm not sure. So this might be due to, so for example, if a person has lactose intolerance,
Right.
so he fails to break down the lactase. If you remember, lactose is going to be breaking down lactase, which is the sugar present in the milk. So if I don't have the enzyme that breaks it down, the bacteria will be growing and will break it for me. So whatever you don't eat, the bacteria will be breaking it down. So I will get a bloating sensation. I will have overgrowth of the bacteria living in the large intestine, causing diarrhea. All this might happen due to intake of dairy products that will contain the lactose. But generally speaking, why people do not drink lots of dairy? If you drink anything above your needs, or you consume anything above your, if you eat lots of meat, for example, you're gonna have this bloating sensation because this exceeds your ability to digest. If you eat or consume anything above your capability to break down, this will directly cause maldigestion, and whatever you will fail to break down, the bacteria is gonna grow faster, causing you this bloating sensation, gases, diarrhea in some cases. All right. Also, might be the reason fresh milk, for example, if without being boiled, without being
Pasteurized.
Yeah, so this might contain bacteria, which are gonna be infected. All right, so it needs specific measures to treat the milk before consumption. This might be another reason. I'm not sure why a specific person might be not willing to drink, but not too much. Too much is gonna harm any person.
What about if you can have the powdered milk, you can mix it and drink it, it's okay, but you cannot drink whole milk, anything from the dairy, that's include cheese.
If you mix it with,
And you just can't have them, it just make you sick.
yes, this
Like
might be
like-
due to lactose intolerance. This might be due to lactose intolerance.
Just too
But
heavy.
regardless, you take the lactose free, it still make you sick, you can't have those. So I'm just like thinking, is that the chemical that mix, like the
Is it mixed?
preservatives on it, or?
I'm not sure. It might be problem with the intestine in general.
It might be just too
not
heavy.
be able to absorb, might be, I'm not exactly sure. If it's lactose intolerance, they will have reaction even if it's lactose free in some cases. All right. But do they have a reaction with non-dairy products? So if they drink, for example, almond milk, Will they have any problem?
Yeah, soy.
They still have it.
Mhm.
So it might be something not related to the milk. It might be something wrong with the Crohn's, ulcerative colitis. I'm not sure. What are the symptoms?
Like flow like.
So only with the milk or not. So I'm not sure what exactly they might have. But it needs to be diagnosed by diagnostic tools. Alright, so you need to take samples, you need to look under the microscope what's going on. Alright. Alright, so back where we were discussing the innate immune defenses. First, immune defense, which is non-specific that we mentioned. This was my surface barriers. This includes the skin and mucous membranes. And we mentioned the non-specific innate immune cells. Those are my neutrophils, macrophages, and natural killer cells. Another innate immunity, immune defense, is going to be based on chemicals that we're going to be producing. Those chemicals will act non-specifically, like what? Like my interferons and my complement. So what is my interferon? What's my complement system? So looking on here, I've got a cell which is infected by a virus. Virus is an intracellular infection. What I mean by this is one of my cells. This is the virus. Is the virus, is it living or dead? It's in between. So outside of a host cell is going to be just a chemical. Once it finds a host cell, it will be able to form the copies of itself and will be able to survive. Alright? So what happens if I get exposed to a virus? A virus will have its genetic material. This is one specific type of virus. Not all the viruses will be infecting the cell in the same way. We can discuss the viral infections in more details if you're taking microbiology. Alright, so this virus, let's say, did infect this host cell and inject its genetic material inside the host cell. So in the virus, we don't have the mitochondria, we don't have ribosomes, we don't have anything to form copies of myself. So what I will do, I will inject the DNA or the RNA according to the viral type. And this genetic material is going to be integrated by one way or another with the DNA of the host cell. So we'll be inserting myself in the host cell. And I will be using all the resources available in the host cell. So I will build up copies of myself. So I will be using the ribosomes of the cell. I will be using the ATP of the cell. I will be using the amino acids of the cell. I will be using the sugar groups of the cell. We'll use everything from the cell to build copies of myself. Use ribosomes, use the DNA polymerase, the RNA polymerase, everything is going to be used on here from the whole cell. And as a result, I will form thousands and thousands of copies of this virus. What's going to happen at the end? Host cell will rupture, releasing those viruses to the surrounding, infecting neighbor cells. As far as I get exposed to a host cell, the virus will keep proliferating, infecting other cells, causing them to rupture, releasing copies of itself, infecting the surrounding cells. So how would I prevent the progression of a viral infection? In this way, I will have an infection on all my body cells with any viral infection. How come I will be able to reduce the progression of this infection? What do you think? Antibiotics are not going to be helpful in case of a viral infection. Antibiotics are antibacterial. antiviral, yeah, antiviral medications. But if you've got flu or you've got any viral infection, why you don't take antiviral medication? Because simply you're gonna get rid of it. How do you get rid of it normally without anything from outside?
Your body.
Yeah, immune system. Yes. Immune system. This is the topic that we are discussing. How? This is my question. How do we stop the progression? So natural killer cells will find this cell and will kill it before it ruptures. One way, as we mentioned earlier, because this viral infected cell will fail to present its self-antigen, and as a result, it's going to get destroyed by the natural killer cell. This is one way. Other ways that will reduce the progression of the disease is that is this infected cell, do I have any way to save this infected cell?
No.
No. There is no way I can save this cell. But what this cell is going to be trying to do is to save its neighbors. So once it gets a viral infection, it's going to turn on specific genes on its DNA that codes for proteins called interferons. It's like an SOS to be sent to the neighbor cell. So take care, we've got a viral infection inside, we're gonna die, save yourself. Alright, this is simply the interference. So once I got a viral infection, turn on gene coding for interferons. Interferons are going to be released from the infected cell, and it's not meant to save the infected cell, it's going to be saving its neighbors. So the neighbor cells, once they receive the interferon signal, so the interferons will be binding to the receptors of the neighbor cells, this will send a signal to the DNA of the neighbor cell to produce antiviral proteins. And those antiviral proteins will be blocking the virus from injecting its DNA and from integrating its DNA with the neighbor cell genetic material. So is the interferon saving the first infected cell? No, it's just reducing the progression. It interferes with the viral infection. That's why we call them interferons. It interferes with the viral replication. Alright, so you see on here, interferons is going to be the SOS. It's going to be inducing the other cells to produce antiviral proteins, and also they will be mobilizing macrophages and the natural killer cells. We've got a viral infection, get ready. This virus that will be released is going to infect other cells, so I'm warning the natural killer cells, I'm attracting macrophages, natural killer cells, to attack any cell which will get infected by this virus. Am I a specific immune response, or I am not a specific immune response? Is this against one specific virus or any viral infection? It's any viral infection. I am part of innate immunity. So whatever, mumps, measles, rubella, whatever you're gonna have, hepatitis, we're gonna be producing interferons warning the neighbor cells. Alright, so one treatment that we didn't have years ago that helped millions of people to get rid of hepatitis B is gonna be the interferons. So we've got interferons or interferons to interfere with the progression of the viral infection. All right? Questions?
Can you take a break, please? Or is it too late?
Whatever. Alright. So, we will not be leaving early under any means anyways. Alright, so. Was it we did take our house? Great. Alright, so I need to get done with this and we have the lab as well. So
Is at the point of the immunization shot?
we need to rush. Yes.
Is at the point of the immunization shots?
I'm not sure.
But I'm saying that is that the reason why people push for immunizations?
Immunization?
Yes.
This is different than immunization. This is the treatment. I've already got the infection. I'm not building up immunity before getting the infection. Immunization, you don't get the infection yet. You're activating the immune system against an infection that you didn't get yet. Alright, we're gonna discuss it. It's part of the adaptive immunity next time. Immunization is gonna be discussed in details next time. Alright, so we can have a break in 5. We come back, start our discussion of the blood typing class.
Sarah, good thing we have a lab today. That's a good thing we have a lab today. Yeah, lab. We got a lab 9 till.
Yeah, it's gonna be this.
I think everybody forgot to have lab. What nobody laugh about when I said dairy?
I don't know, I guess it's just like how the question came out, why they laugh, I don't know.
I was like, dairy.
No, yeah, you see it right, it just probably is just how you ask the question, why they laugh.
Well,
You shouldn't say it, so.
I was actually going another direction on it, but
How many minutes we use so far?
Cause, be
a lot of
honest,
people don't drink cow's milk because of the
It's less than 100%. It's still.
cause like my daughter, when she drinks cow's milk, for some reason she always have like mucus and stuff.
yeah, cause she always with it, she just can't have it. Her body is not
She likes milk.
tolerated.
She don't like throw up or nothing like that. Because
What my whole family is can't drink, like, gallon of milk, I can't buy them. Even cheese, we get sick from. But then, you know how you go to see, you get all those Carnation buttermilk? We drink that all day, it doesn't mean, it don't make us sick. It's just like the whole milk, like the gallon milk, we just can't do it liquid.
I just
It's something either they mix or to preserve.
so I don't drink. That's what I'm saying. I don't drink cow's milk anymore. I drink like almond milk or coconut milk. But
Well, sometimes if you boil it and see if it works.
I'm just saying is that, because I noticed when I did drink cow's milk, I always get indigestion. I always get indigestion. Or not even just because of the lactation of things. I start off not getting the one that's lactate free.
It could be lactose free. It's the shame. Some do not like what they put in the milk kind of mixture like to preserve it. That could, it's a type of chemical. It's not the food with your body, so can make you sick. Because I take the lactose, it just do the same thing. I take the soy, we just don't tolerate that beer.
Yeah, I don't drink soy milk.
So it's not you, it's something in it, not in you with your body.
Any grade? And that's 450, you still even have a chance to get an A in class. If you have less than 450, you're gonna have extra points added to the other 32 plus, which are extra credits. So even if you have 420 something, you can still get an A in class.
Hard to get that.
You got your grade? You get your grade? You get your grade?
Yep.
Yeah, so I did just figure out that your lecture part was not good.
I figured that one out.
Not the test itself, your performance.
I know.
I didn't expect it to be like this. So you surprised me by the lab. You did get more than what I was expecting in the lab. You didn't get what I was expecting in the lecture. I'm not sure. The lecture was supposed to be the easiest part.
That was not the
Yeah, it seems like you all focused more, put more effort towards the lab and you forgot totally about the lecture.
Yeah, the lecture part was more focused on the nutrition side than the,
Yeah.
that's what, or,
So I've seen that like it worked fine with you having the word list. Like I see the average of the lab was much higher than the previous ones.
Yes.
This is much higher than the previous two labs, but the lecture part is surprisingly much lower than the average of the last two lecture exams. And this was not the case in my other two classes. I'm not sure what's going here.
There was a lot of.
So my other two classes, one class did maintain their same performance. So what they are doing, so whoever is doing good did do good, and whoever is doing bad still gonna be did bad. Right? So nothing changed from the second to the third, and for the Deanwood, they did actually have a much higher average in both parts, lab and lecture, compared to the previous one.
So you got Deerwood better than them.
Is that your Saturday class?
Saturday is again, it was the same appearance of the graph. From the analysis, from the statistical analysis of the grades, I did see a major drop in the lecture part, in the lecture exam in this class.
I think we focus so much on the reproduction and not as much on the nutrition and all that, and that's what I thought was the primary focus on the lecture exam, was the nutrition.
The lecture exam,
I mean, I thought.
I believe they were equally weighted. Equally weighted in terms of the size of the chapter, like how big is the chapter. So I cannot get as much questions from the metabolism as I did for the reproduction. So if you notice, we did spend much more time with the reproduction in class compared to the metabolism and digestion. So I believe like both combined, metabolism and digestion were equal to the reproduction in terms of weight. Is this what you meant?
That's what it meant, but I didn't find it.
So yes, metabolism and digestion were almost equal combined to the reproduction, because reproduction has much more material to cover. Alright. So hopefully we're gonna do better on the next time. Hopefully.
Was the reproductive better than what it used to be in the past for you? Like the grades, or is that the same?
And
So I know you say usually people do bad in the reproductive.
so a lot of people do bad on this test, generally speaking, the lab part. But I did move it. I did move it earlier. So I did move the reproduction, digestion, metabolism to be the third exam rather than the last exam. Alright, but you did actually, your performance was not expected. So you did higher than what I was expecting in the lab, but lower than what I was expecting in the lecture.
What was the highest you can get in the lab?
110. I'm not sure if any did get 110, but I've seen like a couple of 100 and something, like 180, 9. It was not uncommon. It was not uncommon. But only few people did get 100 out of 100 in the lecture part, and every time I get at least 4 or 5 who get 100 and something on the lecture part. So all the curve did shift down on the lecture part, and all the curve did move up in the lab part.
So it went up for the lab and down for the lecture, but for the averages for the entire test, how does that work?
Almost the same. Almost the same like the previous time.
Yeah.
So it seems that you just did move your effort from one test to the other. Alright, so today we're gonna have our blood typing lab, and these form groups of 5 to 6.
Genius! Genius!